So for this lesson, we're going to be talking about motion graphs again, but we're going to try and generalize all the types of graphs you just seen. So if you remember from the last lesson, we essentially took a story and broke it down into different types of motion. So there are some common trends. So what I have here is a chart. This chart's going to have 9 different graphs on it, and these are going to show the 9 basically common graphs that you are going to encounter. Anything I draw in blue is going to be considered positive, and anything in red is going to be considered negative. So very simply, we'll start with the first one. So our first one is a displacement versus time graph. And the whole top row will be displacement versus time graphs. And we're graphing constant displacement. And so this is pretty easy. Constant displacement is going to be anything above our x-axis. It can be that far above, it can be this far above, doesn't matter. As long as it's above and it's a straight horizontal line, that means we're not moving, and that means we're also in the positive direction away from our starting point, which would be at our x-axis. For a constant velocity, we need to have a positively defined slope. And so positively defined slopes, they can actually start anywhere. So you could start down here, and this is considered a positive constant velocity. You could start up here, and that's also a positive constant velocity. It doesn't matter where it starts, just matters that we're changing direction to gradually get more positive. The last one, so remember this is in displacement versus time graph, is constant acceleration. So what that idea is, we after each second, we're gaining and increasing the amount of distance that we cover. So, for example, and I guess another way to explain it would be our velocity also gets more and more positive. So, easy one to identify is definitely this one, right? If we look down here, right, and we took the tangent line at this point right here, we could see that, right, not too steep, but if we took a tangent line right here, right, much steeper. And so if you see a line like this, a curve, that is a positive constant acceleration. Another one that could also be positive constant acceleration is something that looks like this. You may be thinking, wait, doesn't that go in the negative direction? Yeah, we're covering distance in the negative direction, but if you look at, again, the beginning part right here, this is almost a vertical line. Right? It's so negative. This object is has a very negative velocity. But then when we get down to here, it's almost become 0. Right? If this kept going, right, it actually just mimic very closely the graph that we already drew. So in general, if you have a graph that in any way looks like a smiley face or any part of it, it's going to be a positive constant acceleration. So now we'll go down to, actually let's do the negative ones now. So negatives are not too tricky. For a displacement versus time, a constant negative displacement is just anything below the x-axis. So we're just standing still in the negative direction that we have defined. For a constant negative velocity, it just has to have an overall negative slope. This one's actually really horizontal. We'll do something like that. Right, and again, it doesn't matter where you start. It just matters that you're gaining more and more negative distance. And lastly, constant acceleration is just going to be the opposite of negative constant acceleration will be the opposite of a positive constant acceleration. So for example, we could have one that looks like this, where it just drops straight down, or one that kind of looks maybe like that. Right? You'd be like, oh wait, but that goes in the positive direction. But same reasoning, we start with a very positive velocity, and then we start to become more and more negative. So if you ever see anything that looks like a frowny face, any part of that graph, that is a negative constant acceleration. Now we have velocity versus time. So with this one, if we're graphing a positive constant displacement, well, if we're not moving, if we have a constant displacement, we're not moving, it's just on your x-axis. So that's pretty simple. We go to but I guess one thing to point out as well is that if it's on the 0 right here, we can't actually tell if it's positive or negative. So both of them actually end up being right on your x-axis. So we go over here, we're graphing a positive constant velocity on a velocity versus time graph. So this one is actually going to look very similar to how a constant displacement looked on a distance displacement versus time graph. You just have anything that's above your x-axis. And then following that same pattern, if we have a constant acceleration on a velocity versus time graph, we just get a slope. Doesn't matter where it starts as long as it's positive. Now if we go back here, we already graphed our negative. Ideally, i.e. you can't tell if it's negative. For this one, just below your x-axis. And then for here, we have a negative constant acceleration on a velocity versus time graph. We have a negative slope or something like that, maybe something like this. Those all work. Finally, we're doing acceleration versus time. Well, acceleration is a change in velocity. So if we're graphing then a positive constant displacement, that is no acceleration. So we're stuck right here on this x-axis. And again, in the same way, we cannot tell if it's positive or if it's negative. Similarly, we go to here. This is a constant velocity on an acceleration versus time graph. Well, constant velocity is no acceleration, so we actually end up back here again. In fact, what this basically means is that when you have a constant acceleration and it's on the 0 point, you don't know if you're not moving or if you're moving at constant speed. You could be either of those and it would look exactly the same. Right? These two would look exactly the same. Last but not least, if we go at our diagonal and see kind of like the trend that we have going here, our negative constant acceleration just has to be underneath our x-axis, our time axis, and our positive constant acceleration on an acceleration versus time graph is going to look like that. So the goal here really is just to be able to identify these graphs. So for example, if I were to give you, let's say, let me make one of these lines again. We can Control-C, move it down, right? So if I gave you, for example, whoa, what happened there? That's fine. We'll use this one. It's all good. If I gave you a bunch of different parts of the line, so maybe I have something that, maybe this is a x versus t. So if I had something maybe like that, and then it went straight down like that, across, straight up, maybe then it curved back down, that you'd be able to say, okay, well, this is a negative constant acceleration, this is a negative constant velocity, this is a positive constant displacement, this is a positive constant velocity, and this one right here is again a negative constant acceleration. So you'll be able to look at that and really identify the different parts of the graph. And that's really all I want you to be able to do. When you guys do the Little Mini Interactive Lab, you'll see that a toy car will be moving and it'll be speeding up, slowing down in a positive or negative direction. And so just keep in mind which direction is positive, which direction is negative, and see the type of motion that it makes. So that's really all I have for you today. Just so we're not confused, I'm going to replace this graph so that it's back onto where it started. This is the chart that you need to kind of have memorized. So there's 9 different graphs, but technically, because you can go positive and negative, there's a little bit more than that. So that's it. Have a good day.